So today we're going to discuss the law of cosines. If you look at this triangle set up in front of you, you'll notice that we have an angle and we're trying to find its side opposite. And unfortunately, we don't have the angle opposite this other side, so it's not set up for a law of sines. I would imagine you could still find x by taking and dropping an altitude, finding, I would say, this segment here of that small right triangle, subtracting from 20, finding this segment here. We could then also find this segment here using sine, cosine, or tangent, and then use the Pythagorean theorem to find that. But that's a lot of stuff. Rather than proving the law of cosines, since your teacher probably did that for you last year, I'm just going to remind you what that is. Law of cosines states that any side squared is equal to the sum of the other two sides minus 2 times the product of those two sides multiplied by the cosine of that initial side's opposite angle. And we're going to use the law of cosines when we're given a side angle side or a side 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 situation. So if we go back to the problem we started with, we notice we're given a side angle side situation which sets up perfectly for the law of cosines. So I want to find a side. So I'll say x squared is equal to the sum of the other two sides, that's 14 and 20, squared, minus 2 times the product of those two sides, times the cosine of the angle opposite that initial side. Plugging all that into a calculator, we get x squared equaling about 76.77. So x is equal to roughly 8.76. So this side here is 8.76. If I wanted to find the remaining parts of this triangle, I think it would be easiest to use the law of sines. Now let's draw a picture. We're given that angle A is 70 degrees. We call this angle A and 70. Here's B and C. So the side B is opposite the angle B, so that's 480. And C is 520. And we're going to go through and solve the triangle, which means find all sides and angles that are missing. So again, this is set up for a law of cosines. I'm going to say a squared is equal to 520 squared plus 480 squared minus 2 times 480 times 520 times the cosine of 70 degrees. Plugging that into a calculator, we get a squared equivalent to about 330,063.5. Square root that. A is equivalent to about 574.51. If I want to find angle B, I'd say the sine of B over 480 is equal to we'll take the sine of 70 degrees over, we just calculated 574.51. Therefore, the sine of B is 0.785 roughly, and angle B equals about 51.7 degrees. Once I have those two angles, I subtract and get my angle C. So I take my 180 degrees minus my 51.7 minus my 70, and that gives me an angle C equaling 58.3 degrees. Let's do another. In this case, we're given three sides, and like I said before, Law of Cosines works well with the side situation, so let's go A being 12, B being 13, and C being 15. And we'll find the missing pieces of this triangle. Again, let's take and say that 12 squared is equal to 13 squared plus 15 squared minus 2 times 13 times 15 times the cosine of the angle opposite that initial side. So that's angle A in this case. So next we're going to try to solve for A. I would take 12 squared, subtract 13 squared and 15 squared, divide that by negative 2 times 13 times 15, and that will give me the cosine of A. If I take the inverse cosine of all of the information on the left, I end up with 50 degrees roughly for the value of A. If I know that's 50 degrees, I can use the law of sines to find another angle. Typically, I find the smallest angles first, so I'll take the sine of B, put that over 13, set that equal to sine of 50, put that over 12, get sine of B equals 13 sine 50 over 12. Take the B is 56 degrees. And then if I want to find C from there, C is going to be equal to 180 minus 50 minus 56. And that's roughly 74 degrees. Let's do one more example. In this problem, we have a situation where there's a tree that's blown over. 4 feet from the base of that tree, we're going to drive in a stake and tie to the tree a 6-foot strap that's 3.5 feet up. We want to know how far from vertical that is. And we'd have to use a law of cosines. We have side, side, side. So we have 6 squared equaling 3.5 squared plus 4 squared minus 2 times 3.5 times 4 times the cosine of the angle theta. So again, 6 squared minus 3.5 squared minus 4 squared over negative 2 times 3.5 times 4. That's going to equal the cosine of theta. Take the inverse of both sides. We're going to get roughly 106 degrees. So from the vertical, that's a total of 16 degrees from vertical. So we have. Make sure you do your lesson summary, do your My Math Lab for this assignment, and we'll talk about it tomorrow.